Good morning, class. My name is Trainer Michael Ciela, and today I'm going to take you through our topic SI units and basic electrical and electronic engineering principles. Welcome, and before we begin our lesson, we need to understand and know the objectives or the learning outcomes by the end of this chapter. At the end of this chapter, you should be able, as a learner, to state the basic SI units, recognize derived SI units, understand prefixes denoting multiplication and division, state the units of charge, force, work, and power, and perform simple calculations involving these units. State the units of electrical potential, EMF, resistance, conductance, power, and energy, and perform simple calculation involving these units. Should also be able to derive SI unit derived SI units use combination of basic units, and there are many of them. But two examples are velocity, which are measured in meters per second, acceleration, meters per second squared. SI units may be made larger or smaller by using prefixes which denote multiplication or division by a particular amount. The 6 most common multiples with their meaning are listed below. Prefix name and meaning. M is mega multiplied by a million. K is kilo multiplied by 1,000. Mil divided by 1,000. Micro divided by 1 million. Nano divided by 1 billion. Picofarad divided by 1 trillion. Charge. The unit of charge is the coulomb, where 1 coulomb is 1 ampere second. The coulomb is defined as the quantity of electricity which flows past a given point in an electric circuit when a current of 1 ampere is maintained for 1 second. Thus, charge in coulomb Q equals to I times T, where I is the current in amperes and T is the time. The second topic is force. The unit of force is the Newton, abbreviated as N, where 1 Newton is 1 kilogram meter per second squared. The Newton is defined as the force which, when applied to a mass of 1 kilogram, gives it an acceleration of 1 meter per second squared. Thus, force in newtons, F equals to mass times acceleration, that is abbreviated as MA, where M is the mass in kilograms and A is the acceleration in meters per second squared. Work. The unit of work or energy is the joule, J abbreviated as J, where 1 joule is 1 Newton meter. The joule is defined as the work done with energy transferred when a force of 1 Newton is exerted through a distance of 1 meter in the direction of the force. Thus, work done on a body in joules W was to F S, where F is the force in Newton and S is the distance in meters moved by the body in the direction of the force. Energy is the capacity for doing work. We have power. The unit of power is the watt, where 1 watt is 1 joule per second. Power is defined as the rate of doing work or transferring energy. Thus, power in watts P equals to W times T, where W is the work done or energy transferred in joules, and T is the time in seconds. Thus, energy in joules, W is equals to P. These notes have been made possible through reference from Electrical and Electronic Principles and Technology 2nd edition book by John Bird. Thanks and have a nice day. Wishing you all the best.